Hello, welcome back. Here we are with, I guess, the full episode 7 of this Blitz BASIC to PlayBASIC conversion. So today what I want to go through actually is the features that were updated since we last looked at a conversion. So we've got support now for variable collisions. In other words, if it finds a variable inside the Blitz code that's actually a function name in PB, it puts an underscore in the variable name and life goes on. And we have some limited text remapping. Yeah, it's not great, it's pretty awful. In Blitz you can do these string operations between a literal string or a variable string and an integer or a float. And it will convert the int to a string and then append them together. Which obviously in PB we don't support, and I can't think of any other basics that do that off the top of my head, but you know, fair enough, whatever. Every basic has its own little niches. So we'll check out, head across to PB, and we'll go to, first we'll look at the print text remapping, have a quick talk about that. This will show the highlight view as well. Right. Wow. The frame rate's about half because we're recording the screen. That's all right. Here we're displaying a normal print statement, and the input example has, there we go, side by side. So the Blitz code for this line was hello world plus A, and it's inserted a string wrapper around the side. Same for the float line. C's been left alone. Now it's okay for some things. It can do that sort of stuff for us, but it can't do the more complicated expressions. And the reason for that is simple: is that it doesn't actually do expressions. What the translator is doing, known sort of patterns. It's not a transpiler. To do that, it would actually do a full compilation of the source and then output. Kind of like PB outputs bytecode, but this would output source code that does the same operation. Another example I'm looking at today was to do things like, I picked a section of the Blitz help files and ran this. This one does a few more wrap commands. It does things like you can load an image, set the image handle, etc. So the wrapper on the conversion side now can produce a working version of this program. Still a few little syntax problems, like the brackets are missing from the CLS function. I can't just let that fall through to PB CLS either, which I thought I could, but they're different. In Blitz, you've got a secondary command for setting the CLS color. In PB, we add the CLS color after the command, so they're actually different. Not a big deal, but it's just one of those little differences we've got to tweak. Let's get out of that. We'll go to our Torus example. So the main changes since the last time we looked at this thing here, we've got our support for our data statement, remapping of course. We're handling labels now, we didn't do that before. We're handling our variable collisions, so this section of code here is almost 100%. Before, it was using a variable called FPS, which in PB terms is a function, of course. So if we try to compile that, we get a syntax error. We've got our string additions here that we've inserted. See the pink color here? That's to show me that that's a modification that the translator has made to the source. So I can just see it in the output a lot easier. I'll probably add maybe a few more sessions to it to add some of these wrap things here, and maybe make some of those functions a bit smarter, and maybe trap some of these to replace them with shortcuts in PB. So the code becomes something that more approximates what it would have been like if it was written in PB to begin with. Can't guarantee how much further we'll get with that, but the goal here is to get something that's pretty, close enough that you can make a small number of modifications and get it to work, rather than have to bust a gut to get the whole thing to work. That's assuming that the wrapper has support for your functions you're using. And given the size of the wrapper at the moment, it probably hasn't got support for the things you're using. It just does basic image support and some basic input from Blitz. Anything outside of those functions, you'd have to roll yourself, I'm afraid. I really like this method for drawing highlighted text. We're losing a bunch of frame rate here, but yeah, it makes me wish I'd done the IDE the same way. It's a lot easier to do things, or most things that you need to do, except things like finding where you are in the source. At the moment, there's no display tree sort of cheats that are in the stream. What I mean by stream is the document's just a big long list of these linked tokens. So each token's classified as a thing, and then it's rendered as that color when it comes time to be drawn. So the word global has been tagged as a keyword. Num vertex is a variable in this case, and there are different colors, comma, etc. Probably should be blue, shouldn't it? Whatever. My point is, though, is that you've got these separate numerical representations of the document, and each token has its own string. So it can have, global can be a longer word than that, or any sort of variables can have a variable length to them. So things like variables can be a variable length. You can step through them. So to make something that would edit the code, you can just step from each link and then index within the text when you're making changes to that text. And as you move forward, you move to the next link. Whereas the old one in my sort of IDE was using a combination of strings and tokenization. So it would work on the document in strings and then sort of convert back, and then the searching that was looking for identifying the variables and types, etc., which was all synchronous. It was all one loop. It was just each update it would process some more lines of code or make any edits that have been made since the previous frame, etc. That would work much better like this. In fact, it would be a breeze, to be honest. And normally when I'm not capturing, this runs at about 200 frames per second without any optimization. Just a quick recap. When the screen's not moving, we don't have to redraw the whole frame. We can just redraw the frame to the background and refresh it twice, and then selectively update what's been modified. So if we're in an IDE situation, if we had the cursor over the word width, and I was typing into width and changing that word, then only this line needs to be redrawn unless something destructive has happened to the rest of the document, like you've opened up a block of, like a rem block or something like that. That would have to change the rest of the document, but normally you wouldn't have to. But at the moment, we're drawing the whole screen, every token as we go through, and as I scroll down, we're still drawing the stuff off the top of the screen. Crazy. Anyway, let's get to what we've been doing lately, and we'll run this in debug mode. Just hit F7. And I'll just grab that converted code up here somewhere. There we are. Down the bottom, Control C. And let's do another port of it. So cut and paste her into a nice new project. We won't bother saving it. Go this to the top, and that's a location of this file where it's constantly in that location. Let's hit compile and see how far we get. Yeah. Okay, so that problem's that's still a problem where we've got a type name and an array name the same. So there's internal potential for collisions. So that's still a problem. Because in PB you can't do that. So in Blitz, obviously you're allowed to do that. No big deal. Once we realize something. Poly was the other one, was it? Yeah, poly and something else. That one. Hit compile again, thanks. Our CLS function. Lock buffer. I think lock buffer actually wants us to an image. Exit function. No, it's something else we have to trap actually. This can be worked out, I think, anyway. Since merge function here has been allotted an assumed return value of 0 as an integer, because it wasn't declared with the return statement in the original code. If I find a return in here, I could probably update that to append whatever this is here on the end of here, which would make sure that if it hits the exit, it's going to return the same value as what it would return if it hit the end function. If you know what I'm saying. Alright, lock buffer again. Unlock that buffer. There you go. Now it's not working for the same problem we had in the previous edition. It's the precedence of those shift operators. So if we go to, where are we? That was the draw edge function, wasn't it? Alright, so we got a polygon. Find here, and yeah, it's in draw edge, the problem. The problem is this shifting. We're working with integers, and the original code is doing a shift to the left in place of a multiply. What I could do here is I could substitute multiply by 8 because that's a literal. But I'm not even checking for this as a problem. So if you use lots of shifts or this kind of logic in your program too, then that's something to be aware of because it's not aware of this problem. Obviously in Blitz, what's happening is that the shift has a higher precedence than, or the same precedence as addition. So when they're sitting in this order, it would do the shift first and then add the slope. But in PB, it must do the addition first and then do the shift. That's right. Running. Now again, it's running like a slideshow because of the lock buffer stuff we've already established. Hit escape to get out of it. If I go, that's the draw strip, isn't it? Draw horizontal line. I'll just move those. I'll show you something. We'll lock the buffer, which will be the screen, and for the entire batch of polygons, unlock. So there we go. There you go. Pretty cool. So I think we're probably averaging somewhere in the mid to high 30s there. And we haven't done any of the optimizations we made to the last one. So grab poly in here. It's still doing lock buffers in here, but I add some logic to the wrapper to handle a relock request. So We can actually just get rid of those. I'm still using the wrapped right pixel, so we don't really need to do that, surely. I wouldn't have thought so. .c x y underscore RGB, which is the color. It just saves, calling this function every pixel and calling this wrapped function every pixel. It's a lot of extra work. Not sure if you can see that, but our average is up in the around 58 frames per second while we capture the screen. It automatically exits because I've got a fail safe in that the main loop up here somewhere. There it is. So after it renders 500 frames, it just quits. Because initially I was concerned about it taking a long time to draw each frame. But yeah, there we go, peeps. Hopefully if that's sort of impressive, I guess. I could show you the wrapper, I guess. The main project has nothing in it, of course. The wrapper is just the file over here. It's got a bit more stuff in it than I thought it had, but not a lot. So when I say wrapper, I mean these BB function things here, they actually do wrap one-to-one in some cases. Then in other cases, they're like when you create an image, we're using new image because Blitz doesn't use indexed images. So we just request an image and we just get back this handle. So in our case, the handle is just an integer. And it's storing some data about the image from then on, like its width, and it's got a centered handle, etc. So we can mimic some of the behaviors of the language. If you try to load an image that didn't work, it'll make a little dummy image thing in here for you. Why not? Why not? The beauty of it being wrapped. But this is just a bit of PlayBASIC code. You can expand this and add other functions, add other wrapped functions that approximate what the original command did. And the closer you get, the better your converted result will be. I'm not saying it'll run fantastic. Don't quote me on that, and don't quote me. You will have to do some work. It's not magic, but I think if you're familiar with Blitz, you'll be able to get something running in PlayBASIC to some degree. All right. Let's jump back to here for a second. What else we got in here? Anything else? No, I think that's about it actually. That's a rendering loop for the screen, by the way. That's the ZX highlighted view. The document itself is just this. So we're passing in a document index. This project actually uses a bunch of sort of associated arrays or handles for remembering arrays. So in this case, you can load in I've called it here a Blitz conversion project. It's a bit of a mouthy thing. We'll grab the index, and this is stored in an array. So we can have multiples of these source files being loaded and converted into memory. Each source has a document, which is the tokenized form of the source code. We sweep through that. I'll show you actually. I'm not sure if we've done this before or not, but so we open up a new Blitz project, we grab the file name, grab the path for it. It'll want an absolute path up front, and it needs that because if you have include files in your in this document, it needs to locate the file probably relative to the original file. So it needs to know where it was. If the file exists, we go, great, let's add a new project to this global array, get a pointer to it, set the main source and path so we can refer to those later on, and then load this thing in and convert it to a document. And this is this Lexing library over here. if you've had a look at the syntax HTML library, you've seen this code. It's pretty much the same thing, except I've made some additions to it since then. Some of the stuff you can just do with tables, really. I mean, honestly, yeah, you probably should just use tables for a lot of that stuff. You know, whatever. So we load it into a document, and that document is this tokenized form. Each token's linked to the one next to it. So we've got links forward and back, so we can move forward and back through the document. And initially, all of the tokens will be sequential. They'll be from, because they're all just sitting within an array, so it'll be starting at, you know, I think it probably starts at index 1, I guess, because 0 is used as the end of the list. So token 1 links to 2, 3, 4, blah, 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 all the way through until we reach the end of the document, and then we can do insertions and deletions and do searches on that thing without ever having to do comparisons with text. So we can just skim through and do our job. So we load this document from the source file. We throw the source file away, we don't need that anymore. And we just call the converter. And this just does a bunch of sweeps over the document. That's all it does. So we pass this our conversion project, which has the current document we just loaded, which is the tokenized view of this thing. We have a quick check to see if it exists. If it doesn't, exit. We run through and look for any include statements first. Before we do any changes to this thing, we just run through it and go, well, what do we need? You know, is this something we can do? The next one does merge of keywords, which handles things like end function, end if, else if, all those two-word variations that Blitz seems to like. Fair enough. We look for labels through the whole source code, which is in Blitz they're like a labels in this format. It's dot label rather than being label colon. It tries to left justify them as well, because that's what PB likes. If you had a label out here, they wouldn't know what that is. That's intentional, by the way. It's to make sure that you couldn't put labels in weird spots and jump into weird places, because it was confusing for newbies. This was designed for newbies, by the way. You didn't know this. All right, we do the labels, pass. We do the keywords, pass. We scan, find the user-defined types. We run through the functions. For each function, we look at the local scope, build a list of all the local variables in this scope. Once we're done, each time we're doing a pass, we're modifying the tokens if we needed to. So this one here, wrapping. Well, there you go. So we've got two more passes. We're wrapping the command set. So anything that's left over after you've found all the variables, it must be a command call. That's why it's just we're just logically following through, doing step by step. And if it's not a command, then it must be something unknown, probably a syntax error we have no clue about. And all this function here does is it looks at. This is a document loop, so we get a pointer to the current document, which is the structure of it. We make an array called tokens, which is what we're going to plonk our array handle into. So we can pass in a document in and set this up to look at the array inside this document. Get the first link, so I can start processing the tokens within this thing. If it's not 0, if it's not the end of the list, then there's something in the list. We grab this token. If it's a command, we add the BB prefix. If it's a couple of commands that we're specifically interested in, like wend, constant, and end, or print as well actually, and flip, there you go. We've got a few of those that we're catching directly and substituting them. So in the case of, for example, wend, that's the keyword they use in Blitz for end while. I just change the text and let it life goes on. I mean, who cares really? Same as the constant, they use a const, we use constant, and I've just enforced that to be the end statement. The print, we're just passing, if we find a print statement, then we check the parameters after that, or the expression after that, to see if it's something useful. And if it is, we try and butcher it to, if it has combinations of strings and integers, we try and butcher that to make it work. Same as text, it's the same function really. Sorry, it's the same function there exactly. We're just forcing the output token text to this thing and moving on. Who cares? If it was a flip statement, we just stick a sync statement in there because they're functionally identical. Well, I don't think they actually are, but roughly, for all intents and purposes, a flip and a sync are going to be the same thing, so who cares? Math shifts, we're just putting our shift operators in place of their ones. This is the read data command, so it remaps those commands. If it wasn't any of these, if the current token we're looking at wasn't one we're interested in, we just fall through to the bottom and then grab the next token from the list and just keep doing that until we hit the end of the list. That's how it's processed. This last one here, which was added the other day. So we're checking if our product's valid in case we call this thing without actually, which shouldn't be possible really, but we are. Grabbing for this conversion project, we're going what document, in other words, what token array do you have? We grab a pointer of that token array, declare another tokens array local to the function, of course, set this to there so we can access the tokens, and then we just, from then on, it's all the same stuff. So in here, by the looks of things, we've only got, all we're concerned about is looking at variable declarations. We're skimming through all the tokens in the document, the whole source file, and looking for things that are declared as variable or integer variable or float, I guess that is, and string over there. If it's one of those things, we check it with this word heap function I posted on the boards the other day. And if we find it, we add the underscore there. So that's how it actually does the collision. So this word heap, when the program starts, it loads a settings file of all the PB command names. There's a lot of possible potential overlaps of those things. I mean, here, since we're modifying it too, that might potentially could cause a secondary collision somewhere else, and we're not checking for those things. The idea here is to get a good translation by using a simplest logic that we possibly can. We're not trying to make it do the world's greatest translation of Blitz. If that's what you're expecting, sorry, it's not where we are. So anyway, that pretty much concludes today. Let's little look at this thing. We'll try and, I'm not sure what's left to do actually. I'll just run that again. We haven't only got list support implemented. I might leave that for the time being. I think things like the wrap command sets with that don't have parameters, that could be something that we could address. And this exit function thing down the bottom here we ran into before, that could be picked up as well. So those kind of few things there could be amended, and then we add a few, I won't call it optimization pass, but I'll call it more of a pass that will make the code more look like it's PB code to begin with, even though it's not. So you can take your M2 equals M2 plus 1 and just go M2 plus plus. Do shortenings of those expressions. So we might run through and find a bunch of those and just try and get basic things like the math operations, test them, because I haven't tested them at all, and test the string functions as well, and maybe the file stuff, I guess, as well. Put them in the wrapper, and then we can add more stuff to the wrapper if I need to at a later point, or if other people run into some code they want to port, then we've got a framework there to work from. Yeah. But those things don't sound like big jobs. They sound like, you know, small things that can be done. And as you've seen before, we can get we can get our project up and running, and this project here is what? It says 2,700 lines, but I'll bet that's really, you know, probably about 1,200 lines really in practice. Thanks for watching, and we'll see you guys next time. Enjoy.